All right, for 8.8, not a lot of notes, but I'm going to go through a lot of examples to make sure we're okay on this. So our purpose statement is to solve radical equations and inequalities, and then we're going to solve our steps for solving radical equations. The first thing you do is isolate the radical, which means get that whatever's in the radical sign by itself. Then raise both sides to the power of the index, and then lastly you simplify and solve it just like all the basic algebra problems we've done so far. So let's take a look at some easy ones and work up to some more difficult ones. So the first one I'd like to look at is 2 times the square root of x plus 1 equals 14. So the first thing we want to do is isolate the radical. So this is our radical, so we want to get that by itself. So the first thing we would do is divide both sides by 2, and then we get the square root of x plus 1 equals 7. So we've taken care of step 1. Step 2, we raise both sides to the power of the index. So again, it's the square root. If there's no power or no index, it's considered to be a 2. So what we're going to do is we're going to take this side and that side to the second power. So squaring it and square root are inverse operations, so they cancel each other out. So we get x plus 1 equals 7 squared is 49. And then lastly, we simplify and solve. So we subtract 1, and we get x equals 48. It's pretty easy to check these. We can plug it in. 48 plus 1 is 49. The square root of 49 is 7, and 2 times 7 is 14. So we know that we have that one right. So that would be one example. Second one to do, 5, and then we're going to do the cube root of 4x plus 3 equals 15. So again, we're going to isolate the radical, so we're going to divide by 5. And we get the cube root of 4x plus 3 equals 3. Then we cube both sides to get rid of the cube root. So these cancel. And we get 4x plus 3 equals 27. Subtract 3. 4x equals 24. Divide by 4. And we get x equals 6. Again, we can check it. 6 times 4 is 24, plus 3 is 27. The cube root of 27 is 3, and 3 times 5 is 15. So we know that we're right. So you can see, not real complicated so far. Let's make it a little more complicated. 3 times the square root of x minus 5 plus 2 equals 14. So now we've got something also added to the radical. But again, remember, we're trying to isolate this part. So we want to subtract the 2. And we get 3 times the square root of x minus 5 equals 12. Divide by 3. We get the square root of x minus 5 equals 4. We square both sides to get rid of the square root. We get x minus 5 equals 16. Subtract 5, and so we get x equals 11. Oh, add 5, excuse me. Add 5, so we get 21. 21 minus 5 is 16. Square root of 16 is 4. 4 times 3 is 12, plus 2 is 14. And so we've got that right. So it's really nice to be able to check these. It doesn't take very long. So another thing we could have is we could have a radical on both sides. So the square root of 35x equals 5 times the square root of x plus 2. So now here we have trouble isolating the radical because we have one on each side. But we just want to make sure one of them is isolated. So now we're going to do the second step because this one's isolated already. We're going to square both sides. But you have to remember you're going to square this whole thing. So the square root and square root cancel here. And we get 35x. Here the square root and square cancels, so we get x plus 2. But we have to remember this affects the 5 too, so 5 squared is 25. So now we can simplify this, distribute the 25. 35x equals 25x plus 50. We subtract 25x. And we get 10x equals 50. And divide by 10. And we get x equals 5. Again, you could plug it in and check. Let's see a second. If I plug in 5, that's going to be 35 times 5. That would be 25, 175. That breaks into 25 times 7. And so we get 5 square root of 7. If we plug in 5 here, 5 plus 2 is 7, and we get 5 square root of 7 on that side. So it does check. A little bit more of a complicated check on that one. Let's take another one. Let's do a cube root. So cube root of x plus 6 equals 2 times the cube root of x minus 1. So again, this one's isolated, this one has a number in front, but we're just going to work from there. It's cubed, or a cube root, so we take the cube of both sides. So on this side they cancel, and we get x plus 6 equals, remember the cube affects the 2, so we get 8, and then the cube and cube root cancel, so we get x minus 1. Distribute, 8x minus 8. So I'm going to solve this, I'm going to get the x's on the same time, and I'm going to do this at the same time. I'm going to move the 8 over to that side, so I'm going to add 8, and so I get 14 equals 7x, and divide by 7. So we get 2 equals x. So this would be the cube root of 8, which is 2. This would be the 2 minus 1 is 1. The cube root of 1 is 1 times 2 is 2. So again, that checks. So let's get a little more complicated. So we get the square root of x plus 18 equals x minus 2. So step 1, isolate the radical. It already is by itself. So now we square both sides, but here again where you have to be careful. You have to square the whole thing. So here it cancels, and we get x plus 18. And the common mistake is people just square the x and they go x squared plus 4, and they square both of those. But you have to remember that x minus 2 squared means x minus 2 times x minus 2. So we have to use the claw method on this. So we get x times x is x squared. We get a negative 2x and another negative 2x, which adds up to negative 4x. And negative 2 times negative 2 is a positive 4. So now we have a quadratic. So to solve quadratics, remember we want to set it equal to 0. So I'm going to subtract x and subtract 18. And so on this side we get 0 equals x squared minus 4 minus 1 is a minus 5x minus 14. And you want to factor that. Most use the x method. I'm just going to go ahead and factor that. That's x minus 7 and x plus 2. And so we get 7 or negative 2. Now here's where you have to be careful. If I go to check this, 7 plus 18 is 25, and the square root of 25 is 5. If I plug in 7, 7 minus 2 is 5. So that one works. That's fine. If we plug in negative 2, we get 16, and the square root of 16 is 4, and negative 2 minus 2 is a negative 4. So this is one of our extraneous solutions we sometimes get, and so that answer in this case would just be 7. The negative 2 doesn't work because we're not going to get, when we take the square root, a negative number. So let's do another one of those. So now we're going to do the square root of negative 9x plus 28 equals a negative x plus 4. So again, we're going to square both sides. Square root and squared cancel, so we get negative 9x plus 28. And again, we have to FOIL this, so I'm going to add another negative x plus 4. Negative x times negative x is x squared. We get a negative 4x and another negative 4x, which gives me a negative 8x plus 16. I'm going to add 9x and subtract 28 to set it equal to 0. And so I get 0 equals x squared plus x minus 12, which factors into x plus 4x minus 3. And then we get negative 4 and positive 3. So let's check that. If I plug in negative 4, I get 36. That's negative 9, so we get 36 here. Plus 28, which gives me 64, and the square root of 64 is 8. Plug in negative 4. The opposite of negative 4 is 4, plus 4 is 8. So that one works. Now let's plug in 3. We get negative 27. Plus 28 would be 1. And plug in 3, and negative 3 plus 4 is 1. So in this case, they both work, and there are no extraneous solutions, so you would have two answers, negative 4 and positive 3. Another way they can write these problems. Let's do 3x minus 1 to the 1/5 power equals 2. So you could write this in radical form if you wanted. This is the way the book does it. They would change it to radical form and go the 5th root of 3x minus 1 equals 2. And then we would take the 5th power of both sides. The 5th root and the 5th power cancel. So we get 3x minus 1 equals 2 to the 5th, which is 32. Add 1, 3x equals 33. Divide by 3, x equals 11. And we can check it. 3 times 11 is 33, minus 1 is 32, and the 5th root of 32 is 2. So that checks. Now, another way to do this is, and this is the way I would do it, is since this is a 1/5 power, we can just do the reciprocal power to both sides. So take this to the 5th power and this to the 5th power. Because power to a power, remember, you multiply, and 1/5 times 5 is 1. So you would automatically go to here because these would cancel and you get 3x minus 1 equals 32. Saves you one step. So you can see there's not a lot of difference between them, but it's another way to do the problem. So let's take a look at another one of that type. 3 times x plus 6 to the 1/2 power equals 9. So remember, we want to get this radical by itself. So you could leave it this way, or you could do this, square root of x plus 6. Then we would get rid of the 3. And get the square root of x plus 6 equals 3. And then square both sides, so it's really the same as what we've been doing now. X plus 6 equals 9, subtract 6, and so we get x equals 3. Check it. 3 plus 6 is 9, the square root of 9 is 3, 3 times 3 is 9, and so we're okay. Now again, the other way to do this would have been to divide the 3 right away. Get x plus 6 to the 1/2 equals 3. Then again, the reciprocal of 1/2 would be take this to the 2nd power and this to the 2nd power, so these would cancel, and we'd go right to here. x plus 6 equals 9. So you can see you save a few steps doing it that way. But either way, you get the same answer. So whatever seems to work best for you. Now, the last thing you're going to do is some inequalities. And this is where you have to be a little bit careful. So, if we have the square root of 2x plus 4 is less than or equal to 4. So we do the process the same as it was an equal sign. So we're going to square both sides and get 2x plus 4 is less than or equal to 16. Subtract 4. 2x is less than or equal to 12. Divided by 2. X is less than or equal to 6. With inequalities, we have to be a little bit careful, and then we check this to start with. Remember, we cannot take the square root of negative numbers. That gives us an imaginary solution. So we have to consider that 2x plus 4 also has to be greater than or equal to 0. It can't be negative. So now we solve this. So we would subtract 4 and get 2x is greater than or equal to negative 4. And then divide by 2, and we get x is greater than or equal to negative 2. This is an and because we have this, and we know that this has to be greater than or equal to 0. So that means we're going to combine these two. So x we know is less than or equal to 6, but it's also greater than or equal to negative 2. So we get our answer written this way. Okay, because remember, you can't take the square root of negative numbers. So let's look at a little more complicated absolute value problem. So 3 times the square root of 2x plus 6 is plus 2 is less than or equal to 11. So again, we're going to isolate this first. So we're going to subtract 2. We get 3 times 2x plus 6 is less than or equal to 9. Then we're going to divide by 3. And we get the absolute value of 2x plus 6 is less than or equal to 3. Square both sides. So 2x plus 6 is less than or equal to 9. Subtract 6. So 2x is less than or equal to 3. And divide by 2. So x is less than or equal to 3/2. Now we have to remember, we have to consider that 2x plus 6 has to be greater than or equal to 0. Subtract 6. Divided by 2. So x has to be greater than or equal to negative 3. So it's less than this, but it's also greater than or equal to negative 3. And so that would be your final answer. The other type of inequality you could get, one last problem. That I'll go over. The cube root of x plus 2 is greater than or equal to 1. So it's isolated. We cube both sides. So this cancels. We get x plus 2 is greater than or equal to 1 cubed is 1. Subtract 2. We get x is greater than or equal to negative 1. Now, this is the cube root. Remember, if it's an odd index, we can deal with negative numbers, so we don't have to worry about x plus 2 being positive or negative, because we can handle that. So in this case, this would be our answer, because we don't need to worry about this having to be a positive number. So those are examples. Hopefully that's helped. Your assignment is page 633, numbers 27 to 51, the odds. So hopefully all those examples helped. There's more in the book if you need them. So good luck.